Witness the thrilling transport of massive cargo at bustling ports using powerful trucks and self-propelled modular trailers. The Powerlifter 35,000 Container Tilter, developed by Power Engineering, is an advanced heavy-duty solution designed to make container handling better, simpler, faster, and more cost-effective. With a safe working load of 35 tons, it can lift either a container alone or a container together with its trailer, thereby offering unmatched flexibility in both loading and unloading operations. Because it is a complete freestanding machine, it requires no permanent installation and can be moved or positioned according to operational needs. Furthermore, its drive-through capability allows operators to choose the direction that best suits the workflow, enabling container doors to face either the front or the rear of the trailer. As a result, the machine can adapt easily to various site layouts and working conditions. Since it does not require level surfaces, the Powerlifter 35,000 can operate effectively in locations where ground preparation would normally be necessary. Its simple and effective alignment system eliminates the need for tools or manual handling, which not only saves time but also reduces the physical strain on operators. The fast and secure hookup process further enhances productivity, while the hydraulic clamp attachment allows the operator to push, pull, and position containers precisely, even when dealing with heavy or awkward loads. This hydraulic system ensures safe and stable handling, which is essential for preventing accidents and protecting cargo. In addition, the machine can be equipped with practical accessories such as scales, remote controls, and bridges, which expand its functionality and improve efficiency. These options give operators greater control over the process, while maintaining speed and accuracy during container transfer. Because it is built from robust, heavy-duty materials, the Powerlifter 35,000 is capable of withstanding the demanding conditions of ports, warehouses, and freight yards, thus ensuring a long service life with minimal maintenance requirements. Its design focuses on reliability, so it can perform consistently over years of continuous use, and its user-friendly operation means that even less experienced personnel can work with it confidently and safely. Overall, the combination of high lifting capacity, freestanding flexibility, easy setup, and precise hydraulic control makes the Powerlifter 35,000 a versatile and efficient solution for modern cargo handling. By removing the need for fixed infrastructure and adapting to a wide range of site conditions, it significantly reduces operational costs while increasing throughput. Whether for bulk unloading, rapid container turnaround, or integration into complex logistics systems, it delivers performance, safety, and adaptability in a single package. Consequently, the Powerlifter 35,000 stands out as a reliable, cost-effective, and future-ready choice for businesses that demand speed, efficiency, and durability in their container tilting operations. E-Fighters, the heavy crane relocation project undertaken by Torben Raffin and BMS, showcases the precision, expertise, and coordination required to move a massive Liebherr LR 11350 crawler crane. The process begins with careful planning, ensuring that each component of the crane can be transported safely and efficiently to its new location. Specialized heavy transport vehicles and trailers are deployed, with each section of the crane, such as the boom segments, counterweights, and crawler tracks meticulously loaded and secured. Due to the enormous weight and size of these parts, the team uses multi-axle trailers and prime movers, allowing for controlled movement even on narrow roads or sharp turns. Throughout the operation, communication between drivers, escort vehicles, and site supervisors is constant, ensuring traffic safety and precise maneuvering. The convoy moves slowly to minimize risk, especially when navigating through urban areas or tight spaces. Upon arrival, the unloading process is equally methodical, with cranes and lifting equipment positioning each part in preparation for reassembly. This impressive relocation demonstrates the combined capabilities of Torben heavy haulage expertise and BMS's crane operations, proving that with the right planning and teamwork, even the largest cranes in the world can be moved with remarkable precision. On Con, the transportation of the tunnel boring machine for the Mumbai Metro began at the manufacturing facility, where the massive components were carefully prepared for shipment. Each section, including the colossal cutter head, main shield, and support modules, was securely fastened to heavy-duty lifting frames. Towering cranes with high lifting capacity were deployed to hoist these oversized loads from the assembly area onto specialized multi-axle trailers. The lifting operation required precise coordination between crane operators, rigging crews, and safety personnel to avoid damage and ensure balance. Once loaded, the convoy comprising several trailers carrying different TBM sections departed the factory under strict transport regulations. Police escorts accompanied the slow-moving vehicles, navigating them through industrial zones and along pre-approved heavy-haul routes. The journey proceeded mainly at night to minimize disruption to regular traffic. Upon arrival at the port, the cranes were once again employed to unload the TBM components onto storage areas or directly onto the cargo vessel. From there, the machine was prepared for its overseas journey toward Mumbai. At a busy port in the United States, the transportation process for delivering essential cargo to a power plant begins with meticulous planning and coordination. Large shipments, often consisting of heavy equipment, raw materials, or fuel, arrive at the port by truck, rail, or barge. Upon arrival, each load is inspected and documented to ensure it meets both safety and quality standards before handling. Specialized port cranes, designed for lifting extremely heavy and oversized cargo, play a central role in this operation. Operators work with precision, securing each load with heavy-duty slings or spreader bars. The cargo is then lifted from the dock and carefully maneuvered over to the vessel's cargo hold or deck. Depending on the size and nature of the shipment, the loading process may require multiple crane lifts, careful weight distribution, and continuous communication between the crane operator, ground crew, and vessel crew. Once the cargo is safely stowed aboard, it is lashed and secured to prevent movement during transit. This is particularly important for oversized or irregularly shaped components. such as power plant turbines, generators, or structural modules, which could be damaged by shifting at sea. The vessel then departs the port, navigating through coastal waters and along designated shipping routes toward its destination. Upon arrival near the power plant's receiving port or dock facility, the unloading process begins in reverse using similar cranes and safety protocols. The cargo is transferred to trucks or specialized transporters for the final leg of the journey to the power plant site. This carefully managed transportation process ensures that critical power plant components and supplies are delivered safely, efficiently, and on schedule, enabling the continuous generation of electricity for communities across the region. On Chi, the loadout sequence of a massive offshore jacket module begins with precise alignment of multiple SPMT units. Each self-propelled modular transporter, a multi-axle, hydraulically powered transporter, is configured with the exact number of axle lines required to distribute the load evenly. Once coupled, operators using advanced steering modes such as crab or carousel maneuver the module with millimetric precision. The synchronized hydraulic system ensures constant balance and control, allowing the structure to be guided slowly off the fabrication yard and onto the next transport platform. Throughout the lift-out, strict method statements, including center of gravity and weight calculations, lashing plans, and route clearances, are followed to safeguard stability. A marine warranty surveyor often oversees validations like axle line setup, steering coordinates, and procedural checks to minimize risks. This orchestrated choreography ensures that the enormous jacket is transported safely, efficiently, and accurately toward its journey offshore. At the Ras Al Khaimah yard, Eversendai Offshore successfully executed the loadout of a massive offshore jacket structure for client Rossetti Marino S.p.A. The total weight of the cargo reached 158 tons, comprising a 127-ton jacket, 338 tons of appurtenances including the wellhead module, boat landing, and caissons, as well as 693 tons of piles, eaves, The operation began with careful positioning of self-propelled modular transporters, SPMTs, beneath the jacket and associated components. These multi-axle transporters, with precise steering control, ensured even weight distribution and stability during movement. Slowly, the SPMTs carried the structure from its fabrication area toward the quayside. Coordination between the ground crew and SPMT operators was critical, particularly during tight turns and alignment with the loadout platform. Once at the waterfront, the cargo was aligned for transfer onto a waiting barge. This meticulous process demonstrated Eversendai's expertise in handling heavy and oversized offshore structures, ensuring a safe, efficient, and timely loadout for its international client. The Eversendai Vahana Aryan is a self-propelled liftboat, or self-propelled jackup, built by Eversendai for its subsidiary Vahana Offshore. Designed for offshore oil and gas operations, it features a rectangular hull and 4 95-meter truss-type legs equipped with an electric rack and pinion jacking system. This system enables the vessel to operate in water depths of up to 70 meters by elevating the hull above the sea surface, creating a stable working platform. The jacking trials are critical tests of this system, focusing on raising and lowering the legs, assessing stability, and verifying load-bearing capacity in varying conditions. These trials ensure the vessel's safety, reliability, and readiness before entering commercial service. Successfully completing these tests marked an important milestone before the Ariane's planned delivery to Vahana Offshore in the third quarter of 2017. The Offshore Operational Support Facility building, weighing 550 tons, was transported using self-propelled modular transporters, SPMTs. The heavy structure was carefully lifted and positioned onto multiple SPMT units, which were aligned to evenly distribute the load. Once secured, the convoy moved slowly along the designated route, with precise steering and coordination to ensure stability. Upon reaching the quayside, the building was positioned for the next stage of the project, with each unit positioned on the rail track adjacent to the loading area. A large mobile crane is brought into place, and its lifting slings are securely attached to the designated lifting points on the coach body. Once the rigging is checked, the crane carefully hoists the 51-ton coach, with dimensions of 26.40 meters in length, 2.90 meters in width, and 4.30 meters in height, off the rails and suspends it in mid-air. The coach is then slowly maneuvered and precisely lowered onto a low-bed semi-trailer connected to a heavy-duty tractor truck. After being secured with chocks, chains, and tensioners, the loaded truck departs the rail yard and makes its way to the port's quay. The convoy moves under escort to ensure safety and prevent interference from surrounding traffic. Upon arrival at the quayside, the truck positions itself alongside the designated cargo vessel. Here, a high-capacity port crane, equipped with spreader beams to evenly distribute the load, is prepared for the next lifting operation. The lifting gear is fastened to the coach, and the crane carefully raises it from the trailer. The coach is then swung over the vessel's open hold. With spotters guiding the operation, the crane operator lowers the coach into the cargo space, aligning it precisely with its designated storage position. Once in place, the coach is unhooked, and workers secure it using blocks and lashings to prevent any movement during sea transport. This process is repeated for each coach until all units are safely loaded inside the vessel, ready for shipment. At Derensport, Turkey, the transportation of technological press lines and auxiliary equipment began with the arrival of multiple cargo units by sea. The shipment consisted of 265 packages with a total weight of 3,080 tons and a volume of 35,687 cubic meters. Upon docking, the vessel's cargo holds were opened, and port cranes commenced the discharging process. Smaller crates, frames, and boxed components were carefully lifted from the ship's hold and transferred onto the quay. Heavy lift items, such as large press components, required the use of tandem crane operations to ensure safe handling. Cargo was then placed onto designated storage areas within the port for temporary stowage. Each package was arranged according to size, weight, and reloading sequence to facilitate efficient further transport. Following stowage, the cargo was prepared for transshipment to the Caspian Sea via sea river-type vessels. Heavy loads, notably the crown assemblies weighing 95 tons each and measuring 7.0 times 4.6 times 3.5 meters, required specialized handling. These units were rigged using heavy-duty lifting slings and spreader beams, ensuring balanced lifting to prevent damage. Port cranes, assisted by ground crews, hoisted each crown assembly from the quay and maneuvered it precisely into the cargo hold of the smaller vessel. Wooden cribbing and steel securing frames were positioned to stabilize the load during transit. Lighter and medium-sized packages were subsequently loaded, using forklifts or smaller cranes depending on their dimensions and weights. Cargo was methodically arranged inside the vessel's hold to optimize space utilization and maintain stability. Once all items were loaded, lashings, chains, and tensioners were applied to secure them firmly against movement at sea. This meticulous process ensured the safe transshipment of all components, from the ocean-going vessel to sea river transport, enabling their onward journey toward the Caspian Sea. Heb. At Richards Bay Port, the crew prepared early in the morning to offload the 300-ton Sasol wax reactor. Using heavy-duty slings, a crane lifted the reactor from the ship's hull and carefully lowered it onto a specialized multi-axle trailer. The reactor was then secured for its slow road journey to Salzburg, traveling at 5 to 10 kilometers per hour over the next 2 weeks, ensuring safety and minimal disruption to traffic. EGA. The 180-ton drilling rig is positioned for relocation between 2 large cranes. It rests on 3 6-axle modular transporters, each aligned to evenly distribute the load. The move begins with operators carefully steering the transporters forward in perfect synchronization, ensuring the rig remains level and stable. The path between the cranes is extremely narrow, requiring precise maneuvering. As the convoy approaches the tightest section, the crane support legs, outriggers, on one side present a major clearance issue. To create enough passage space, one outrigger is retracted under strict supervision. This delicate step is executed slowly, with personnel monitoring both the drilling rig's position and the transporter's alignment. Once the support leg is fully retracted, spotters give clearance signals to proceed. The modular transporters move forward at a controlled pace, guided by multiple crew members stationed at key points along the route. Steering adjustments are made continuously to keep the rig perfectly centered between the crane structures. Hydraulic suspension systems on the transporters help absorb unevenness in the surface and maintain balance. As the drilling rig passes through the narrow gap, the clearance between the load and the crane components is minimal, requiring constant communication via radio and hand signals. Once the front transporter clears the cranes, the remaining units follow in a coordinated manner, maintaining load stability at all times. After fully exiting the restricted area, the transporters straighten out and align for the next stage of the move. The retracted outrigger is then extended back into its operational position, restoring full crane stability. The transport team confirms the rig's condition and alignment before concluding this phase. The operation showcases the precise handling required when moving oversized equipment through confined spaces, especially when temporary modifications, such as retracting a crane support leg, are necessary to enable safe passage. The entire movement is executed with careful planning, slow speed, and constant monitoring, ensuring that the 180-ton drilling rig is transported without incident. The Krupp KMK8400 is a high-capacity all-terrain mobile crane engineered for maximum performance in demanding lifting operations. With an impressive 400-ton lifting capacity, it is one of Krupp's most capable models, designed to deliver a combination of strength, reach, and mobility. Whether deployed in construction, heavy industry, or infrastructure development, the KMK8400 provides reliable performance under challenging conditions. At the heart of the KMK8400's capability is its advanced telescopic boom system, which allows for exceptional lifting heights and outreach. The hydraulically extendable boom can be quickly adjusted to suit specific lifting requirements, eliminating the need for excessive assembly on site. For jobs that require even greater reach, the crane can be fitted with lattice jib extensions, enabling it to tackle projects such as wind turbine erection, industrial plant installation, or high-rise construction. BAME. The crane is mounted on a robust all-terrain chassis, combining road-going efficiency with outstanding off-road performance. Its multi-axle steering system ensures excellent maneuverability in tight spaces, while the powerful drive system provides traction and stability across various terrains. This means the KMK8400 can travel swiftly between job sites and operate effectively in areas where ground conditions are less than ideal. By reducing the need for auxiliary transport vehicles, it also helps cut operational costs and setup times. Operator comfort and safety are top priorities in the KMK8400's design. The spacious, ergonomically designed cab is equipped with advanced control systems, clear instrumentation, and adjustable seating, allowing for precise, fatigue-free operation. Safety systems such as load moment indicators, outrigger monitoring, and overload protection ensure that lifts are performed within safe parameters at all times. Additionally, the crane's counterweight system can be configured to suit specific lifting challenges, optimizing stability without unnecessary weight. Transport efficiency is another hallmark of the KMK8400. Despite its large capacity, the crane's modular design allows for relatively quick disassembly and reassembly. This ensures smooth mobilization between sites and reduces downtime. The ability to adapt to different road regulations and load limits makes it a practical choice for both local and international projects. In the field, the KMK8400 has earned a reputation for reliability, versatility, and exceptional lifting performance. It is a trusted solution for lifting specialists worldwide, capable of handling everything from bridge sections and precast concrete components to oversized machinery and structural steel assemblies. By combining heavy-duty lifting power with advanced technology and mobility, the Krupp KMK8400 remains one of the most respected mobile cranes in its class, offering strength, precision, and efficiency in every lift.